Okay, this is the last section of chapter 12 called the normal curve. This is probably the hardest one to kind of comprehend what's going on, but hopefully it'll make a lot of sense. Again, those of you taking the statistics, this is one of the most important things you're going to learn in statistics, even though it's not until chapter 6. So just kind of keep that in mind. So here's what happens. We have for our x values always represent our data values. So just, I made this up. We have a mean of 100 and a standard deviation of 5, just to make it easy. So when you have that, what you can do is you can create a new number line that has your mean in the middle. So our mean is 100, and then we count by 5. So we don't even care what the original data values are. There could have been 100 pieces of data. There could have been 10 pieces of data. It doesn't matter. All that matters is we calculated and got a mean of 100 and standard deviation of 5. We have no clue what the original data values are, which is fine. Okay, so we have 100, and then we're going to have 105, 110, 115. And we only have to go out to 3 because that's pretty much all you're going to have for your standard deviations is up to 3 or down to 3, negative 3. Okay, and then we need to go backwards. So then 95, 90, and 85. Okay, so that's what it could look like if you have a mean of 100 and standard deviation of 5. I could do this all over again and have a mean of 100 and a standard deviation of 10. So then we would have 100, 110, 120, 130, 90, 80, 70, so on and so forth. Or maybe my mean is only 20 and my standard deviation is 2. I could make up all kinds of different number lines. So what we have to do is, again, some really smart people came up with something called the standard normal distribution or the normal curve. What this does is this works when you have a normal distribution. What I mean by that is if you were to draw a histogram, it would have the highest up here and work its way down, so on and so forth. So that's considered a normal distribution. And the reason is because when you get small enough boxes, what you can do is you can draw a curve. Okay, so if you've ever heard grading on the curve, it's not really that much of a thing anymore, but this is what it is. Like you're supposed to have from here to here, those should be like your C's, and then this is your B's, and then you only have that few of A's, and then D's and F's, so on and so forth. So most people do not do that anymore, but that's how it used to be for grading. You were supposed to grade on the curve. All right, so that's what the standard normal distribution looks like, and I'm going to show you a picture in the book here in just a second. So what that means is we need to have one curve instead of having a whole bunch of different ones. So what we do is we change them to z values. So what we do is, again, we'll hopefully once we put a problem with it, it makes more sense. Z values, they all will have a mean of 0 and then a standard deviation of 1. So if these are my x values, right below it, I'm going to write my z values. This is going to be 0, 1, 2, 3, negative 1, negative 2, and negative 3. So for this set of data, 105 would change to a z value of 1. 115 would change to a z value of 3. 90 would change to negative 2 because it is 2 standard deviations below the mean. All right. Now, we're not always going to ask about certain problems. This is how you're going to be what you're going to be able to do. If I give you this information, I can say what percent of students scored below 102. Well, 102 is not on here, so we need a formula to figure out 102, and then we'll figure out what percent it is below that based on this chart. Okay, so this will be on Canvas in the file, so you're going to need to print this off. It'll be 2 sheets. If you can try to print it front and back, that would be easier. But what you can see is when you look up a z-score, what it gives you is the amount that's shaded, and they give it to you as a decimal because this whole curve has an area of 1 or 100%. All right, so again, once we put data values with this, hopefully it'll make a little bit more sense. But so you're going to look up and you're going to find a percent based on what your z value is. Okay, so to work through this, we're going to do example 5 on page 777 about horseback rides. Okay, so in the problem, they tell us that the mean, remember, is x bar is equal to 3.2, and then the standard deviation, which remember is s, is equal to 0.4. All right, so that information has to be given to you for every single one of these problems. Here is the key formula you're going to use. Your z-score is x minus x bar all over s. Okay, so this x represents the number that they're asking about. So just a second ago when I said what percent of students is below 102, 102 is the number I'm asking about, minus our mean of 100 all over 5. That's how you'll calculate your z-score. Okay, so let's think about it. If I want to find a z-score of 105, 105 minus our mean is 100 is 5, divided by our standard deviation, which is 5, which gives me 1. That's how that number calculates. 110 minus 100 is 10, divided by 5 is 2, so on and so forth. So it is very important that you put this in the correct order. Okay, again, just like in 12.5, I'm going to give you or 12.4, I'll give you the formula. You'll get the formula for this also for the test. Okay, again, I'm not going to tell you what it means, but you will have that formula. So for every one of these problems, this is what you're going to have to do is calculate the z-score, and here's how it works. Okay, so here's example 5. Part A wants to know how many rides or what percent of rides are below 3.2 hours. Now I'm going to just calculate it, and then we'll talk about how you could do this without even calculating it. So here's our steps. Z equals the number they're asking about is 3.2 minus the mean, which is also 3.2, over the standard deviation, which is 0.4. So when you calculate that, you get 0. Okay. So for all of these problems, I highly suggest that you draw a curve, and it doesn't have to look super nice. Your mean is always going to be 0, and that's actually what our z-score is also. And then you want to shade what they're asking about. They want us to look at below that. Well, in a normal distribution, these two sides are equal, where the mean splits it right in the middle. So half of it, 50%, is over here. So your answer is just 50%. Now, you shouldn't have to calculate it, but if you want to, you can. All right, now, the way you use this chart that you're going to need to print off is, this one's a little bit tricky because of being 0, but so one side, notice, has the negative z-scores along the edge, and the other side has the positive. So if we look at the positive z-scores right at the top, so you're looking down and across to get your z-scores. 0, 0. So this means a z-score of 0 is 0.5 or 50%. Again, that's because half of the data is below the mean and half of the data is above the mean if it's a normal distribution. Okay, I don't really like that they start with that one because that one's almost tricky. So let's look at B. They want us to know what percent of the rides are below 2.8 hours. Okay. Below 2.8 hours. So again, you're going to calculate Z equals 2.8 minus 3.2 all over 0.4. If you need to round, you always round to 2 decimal places because that's what it is on the Z chart. Okay, when I say Z chart, I mean this big crazy thing with all the numbers on it. Okay, that's called your Z chart. Z values are always rounded to the nearest hundredth, so 2 decimal places. This one you don't have to round. You get -1 when you do that. So when I draw that, I always put this with the 0 just so I know where it's at, and then -1. And again, you don't have to draw to scale or anything. -1, and we want below. So you find the negative part of your chart, which is going to be over here, and here's what I always show. This picture that we drew looks just like this. The left-hand side of it is shaded. So when we find -1 as a z-score, that's going to be our answer. So along this edge, you're going to find -1, 0.0, and then this part up here is 0 also. So 0.1587 means 15.87% is your answer. 15.87% of the rides last less than or below 2.8 hours. I'm going to start a new video so I don't run out of time.